Hardness. Now, hardness is a diagnostic property that we use with minerals to identify them. And it's one of the ones that's less obvious. It's one that you're going to actually have to do some physical stuff with them. You can't just look at a mineral and determine its hardness like you can with its color or its luster or its crystal habit or something like that. But to define hardness in the most simple terms, it's a mineral's resistance to being scratched. So it follows that the harder the mineral, the more resistant or the less easily it will scratch. And we rank hardness on what's called the Mohs hardness scale. That's M-O-H, Mohs hardness scale. And this scale, it's like a scale of a bunch of indices, right? We've got 10 different minerals mapped out, and they act as each of them acts as a little index for things of similar hardness. So for example, 1 on the hardness scale, or the least hard, would be talc. That's the easiest to scratch. 2 on the hardness scale is gypsum. 3 is calcite. 4 is fluorite. And then I'll just say these out. Then 5 is apatite, 6 is orthoclase, 7 is quartz, 8 is topaz, 9 is corundum, and finally we end with, I'll just do ... 10, which is diamond. So diamond is the hardest substance, the hardest to scratch, and all of these then come before it. Now, an interesting note about this hardness scale is that there's no particular pattern. It's entirely just a ranking system. It's sort of like if you were to rank a bunch of students based on their grades, and you were to say that, well, student A is first in their class with a 4.0, then student B is second with a 3.0, then student C is third with a 2.9, then student D is fourth with a 2.7. You saw that there's no real order to that. It's just ranking them without taking into account any sort of pattern. It's not, for example, logarithmic. No, it's just ranking them in order, where diamond is greater than corundum, is greater than topaz, is greater than quartz, and so on. If you want to get into their absolute hardnesses, I think diamond is like 4 times the absolute hardness of corundum, and corundum's only 2 times the absolute hardness of topaz. You can look up those exact values. I don't have them off the top of my head. But yeah, that's the hardness and Mohs hardness scale defined. And then this is a really easy one to test, because all it requires is scratching something against another surface. So for example, a human fingernail is one of the things that we know. It's got a hardness of about 2.5 on the Mohs scale, which if you look means it should be able to scratch talc and gypsum, but not up to calcite. So if we were to actually try this out, I've got talc here. And just a side note, this is a very, very soft feeling mineral. For lack of a better word, it really just feels not hard at all. It feels almost like it's whittling away in my hand, but to actually get to the point, if I'm to scratch this with my nail, then I can feel it. First off, I can feel the surface actually being scratched, and then if we look at it, it's impossible to see in this camera, but I might put a little picture showing it up close, but you can actually see the little scratches that I've left. A similar case with, this is a little piece of selenite gypsum here. If I'm to scratch this with the nail of my thumb, feels almost like a nail on a chalkboard. It's pretty nasty. But there's a very visible area where I made my scratches. Once again, I'll put that up close so you can see it. And then if we move up to calcite, which is 3, it follows that my thumbnail should not be able to scratch this because it's harder than the normal human fingernail. And what do you know? I try scratching it, but nothing happens. So that's just a bit of a way of visualizing how hardness works. And just a little fun fact, a streak plate, which we use to test the streak, another diagnostic property of minerals, has a hardness of about 6.5, meaning anything with a hardness above that actually can't be tested with a streak plate. Granted, most minerals that hard tend to have white streaks, but just an interesting fact. So hopefully this was informative, otherwise good review. Hope you guys enjoyed, and I'll see you in the next video. Ciao.